take a look at polynomial and rational inequalities. And I'll write down the steps for that first. Polynomial inequality. This is specifically how to solve one. Our first step is get everything on the left side, 0 on the right side. Step 2 is to factor the left side. Then set each factor equal to 0. And solve. So set each factor equal to 0 and solve. Now these are called our critical values, critical numbers. Basically that means that's where something important is happening. Now step 3. Using the critical values, the x-axis and a graph, find your answer. If you got a less than or less than or equal to, your answer is below the x-axis. If you have a greater than or equal to, your answer is above the x-axis. If you have a less than or greater than in your problem, you're going to use parentheses. So you use parentheses. If you have a less than or equal to or greater than or equal to, you'll use brackets. Let's take a look at our first problem here. We got x squared plus 4x minus 5 is less than 0. Well, this is a polynomial, and of course the less than's, greater than's, that's what makes it an inequality. First step, get everything on the left side, 0 on the right side. Well, that's done in this problem. Step 2, we want to factor the left side. This factor is using the PST method. Factors as x plus 5 times x minus 1. Then we want to set each factor equal to 0. So I'll set x plus 5 equal to 0, and I'll set x minus 1 equal to 0, and solve these. Take the 5 over, it becomes a negative 5. Take the negative 1 over, it becomes a positive 1. And these are our critical values. So those are our critical values. Now it says using the critical value, the x-axis, and the graph, find your answer. Well, here's the x-axis. Negative 5 would be here, 1 would be here. Clear over here is negative infinity, clear over here is positive infinity. The critical value splits these into intervals, or regions, like this. So this first interval is from negative infinity to negative 5. This next one is from negative 5 to 1, and this third one is from 1 to positive infinity. Well, let's actually look at our graph now and see what it looks like. So I'm going to press y equals, clear. I'll do x squared plus 4x minus 5, and then graph. Now you'll notice that the places it crosses actually corresponds to our critical values, negative 5 and 1. So if I sketch my graph on here, our graph looks like this right here. Now, don't put any kind of effort into making this look nice. That's not the goal of this. The goal of this is to just see where your graph is above and below, which we'll see here in a minute. Sometimes when I do that in class, people kind of snicker like got Alzheimer's or something. I start shaking or something. And it's not that. We just really don't care. And we'll see why. Now this is less than 0. Which means, if I come over here, less than, our answer is below the x-axis. Well, here's our x-axis. The graph is below right here. So this interval is going to be our answer. So it's going to go from -5 to 1. And our problem has a less than. Less than means we use parentheses. So we'll put parentheses around them like that. And that would be our answer. What if I didn't have a calculator? Well, what I would do is I would still go through, find my critical values, just like before. It still splits it up into intervals, like this. What you would do is you'd pick test cases. I'm only going to show one of these. But you'd pick test cases. And what I mean by that is this is negative infinity over here, this is positive infinity over here. So you want to pick a value between negative infinity and -5, like, I don't know, -6. Here we want to choose something between -5 and 1, like 0. And here we want to choose something between 1 and infinity, like 2. It can be any value. So there's nothing special about these numbers I picked. Now what we want to do with those is we want to plug them into our original problem, which was x squared plus 4x minus 5. So x squared plus 4x minus 5, what was it, less than 0? Less than 0. And plug it in here. X squared plus 4x minus 5 is less than 0. And x squared plus 4x minus 5 is less than 0. So if I plug -6 in, I'd have -6 squared plus 4 times -6 minus 5 less than 0. And this is more of a question mark at this point. We're wondering if that's true. Well, this would be 36 minus 24 minus 5, possibly less than 0. 36 minus 24 is 12 minus 5. Is that 7? Is 7 less than 0? No. So this would not be part of our answer. Now if I put 0 in, our second test case, we'd have 0 squared plus 4 times 0 minus 5 is less than 0. And this is a question mark at this point. 0 squared drops away, 4 times 0 drops away, and we get 0 is less than... oops. Okay, assuming I could actually add numbers. Let's try that again. -5 is less than 0, which is true. -5 is less than 0. So this is part of our answer, this interval. And then if I put 2 in here, I got 2 squared plus 4 times 2 minus 5. And you're wondering if that's less than 0. That gives us 4 plus 8 minus 5. Question mark, less than 0. That's 8 minus 5 is 3, plus 4 is 7. Is 7 less than 0? No. So our only place where it's true is from -5 to 1. So if you weren't using the graph, you'd have to do test cases like I just did to figure out your answer. Anyway, I did one of those, so that's good enough. We'll go back to the calculator. It's nicer. Let's see, 15 x squared plus x minus 2 is greater than or equal to 0. Okay. Get everything over on the left side, 0 on the right side. That's done. Then we want to factor the left side. This is the key number. Then it factors as 5x, 3x, 2 plus minus 1. 5x, 15x squared minus 5x plus 6x minus 2. Okay, it factors that way. So then we'll set each factor equal to 0. So we got 5x plus 2 equal to 0, and 3x minus 1 equal to 0. Now solve for x. So I'll take the 2 over, it becomes a -2. And we get x is equal to -2 fifths. Take the negative 1 over, it becomes a positive 1. Divide both sides by 3, and we got x is equal to 1/3. So, if I put those critical values on our x-axis, that'd be negative 2/5. Here'd be 1/3. Now again, this is separating it into intervals. Clear over here is negative infinity. Clear over here is positive infinity. Now I know what x squared looks like. X squared just in general looks like that. If it's a positive number, it opens up. So I don't really need to graph this. I know it's going to look something like that. It's going to pass through here and here, and it'll open up. Well, our problem is greater than or equal to. Greater than or equal to, if I go back up and look at my steps, is where it's above the x-axis. Well, it's above here, so this interval is our answer. And it's above here, so this interval is our answer. So our answer is from negative infinity to negative 2/5, and from 1/3 to positive infinity. Now, infinities always have parentheses on them. Now, greater than or equal to means a bracket. So bracket here, and since I have two intervals, I have to put a union in between them. And that'd be our answer. Now, if you don't feel real good about just going on faith on that, again, graph it. You go to y equals clear, and we got 15x squared plus x minus 2 and graph. And you see mine doesn't look anywhere close to that because we really don't care. We're just looking for where it's above and below the x-axis. Well, let's start a new page. I think I got this saved. Let me double check. This is, what is this? 3.6? Yep, I got them saved. Okay, so we just start a new page here, and then we'll look at our next example. So number 3. We got x squared is less than or equal to 3x plus 3. Well, our first step is to get everything on the left side 0 on the right. So I'm going to take the 3x plus 3 over the left side. So I get x squared minus 3x minus 3 is less than or equal to 0. Excuse me. Well, this won't factor, so we have to use quadratic formula. A is the numbers before x squared, which is 1. B is our numbers before the x, which is negative 3. And C is our number at the end, which is negative 3. Quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So we got a negative 3 plus or minus b squared, so I got negative 3 squared minus 4 times a times c all over 2a. Well, negative becomes a positive 3 plus or minus. Negative 3 squared is 9. Negative 4 times 1 is negative 4 times a negative 3 gives you a positive 12 over 2, which gives us 3 plus or minus square root of 21 over 2. Now, I don't know very much about what this number really means or anything, but I know the minus is less than the plus. So over here, I'm going to have 3 minus square root of 21 over 2. And over here, I'll have 3 plus square root of 21 over 2. And here's negative infinity, and here's positive infinity. Again, this splits it up into intervals. I know what our graph looks like. An x squared means it opens up like that. And to find these critical values means it crosses the x-axis at those points. So my graph would look like this. Now, this particular problem is a less than, which means our answer is below the x-axis. Well, here's where our graph is below the x-axis. So here's where our answer is. So it's going to go from 3 minus square root of 21 over 2, comma, to 3 plus square root of 21 over 2. Let me just double check my numbers and everything here. Okay. Yeah, it looks right, I guess. Yeah. Now, less than or equal to. The less than or equal to means we use brackets. So we put brackets around it like that. And that'd be our answer. Let me grab a drink here. Let's look at our next problem. So we got x to the third. I'm just curious what this my previous upload's doing. Let me look. Okay, that's good. I wasn't sure about actually starting this recording while it was still processing, but I wanted to get as much done as I could. X to the third plus 7x squared minus 4x minus 28 is less than 0. Okay, so we want to get 0 on one side and everything else on the other side, which is done. The next step is to factor the left side. Well, this is grouping. 4 more terms. So I group the first 2 terms together, and they have an x squared in common, and that gives us x plus 7. I'll group the second 2 terms together. They have a negative 4, and that leaves us x plus 7. They both have an x plus 7, so I factor that out, and that gives us x squared minus 4. Now, x squared minus 4 is the difference of 2 squares. So that's dots. Up here is grouping. So this factors as x plus 7 times x plus 2 times x minus 2, less than 0. Now we want to set each factor equal to 0. So I'll set x plus 7 equal to 0. I'll set x plus 2 equal to 0. And I'll set x minus 2 equal to 0. Now solve for x. So I'll take 7 over, becomes a negative 7. Take 2 over, becomes a negative 2. And take the negative 2 over, becomes a positive 2. Okay. Our smallest critical value is a negative 7, so that comes first. Negative 2 is our next largest one, so that comes next. And then a positive 2 is the largest one, so that comes clear to the right. Now here's negative infinity, here's positive infinity. Again, our critical values split them into intervals. I'm going to go double check this on my calculator, but x to the third, if I use leading coefficient test, it's down to the left, up to the right. So down to the left means it's going down here. So which means it crosses here, comes up here, crosses there, then goes up like that, and goes up to the right. Now let me graph this just to be on the safe side. So I'm going to press my y equals clear, and I got x caret 3 plus 7x squared minus 4x minus 28. Then graph. Now again, we could care less what the graph really looks like. We're just trying to see where it's above and below. Actually, by skewing it a little bit, you get a better picture. So this is down below, then it comes up above. So it does look exactly like that in terms of above and below. Now our problem is a less than, which means our answer is below the x-axis, which is here, and it also is here. So we're going from negative infinity to negative 7, and then we're going from negative 2 to positive 2. Infinities always have parentheses on them. This one has a less than, which means these are also parentheses, and we put a union symbol in between them. And that's our answer. Let me start a new page. Let's look at our next problem. Pretty soon I'll rudely be flipped over, probably. When it's doing its processing, when it finishes, it doesn't care if I'm doing anything else. It just willy-nilly puts me into whatever it wants. Sometimes it puts me in Internet Explorer, sometimes it puts me into the actual software package. So just a warning, I'm seeing this is getting close to getting done. Okay, this is an oddball case. First step, get everything over on the left side, 0 on the other. That's done. Second step is to factor the left side. Well, this factors using the PST method as x minus 2 times x minus 2. Now set each factor equal to 0. But these are actually the same, so I'm just going to set one of them equal to 0. And then solve it. And we get x equals 2. So here's 2, and here's negative infinity, here's positive infinity. Again, that splits it into intervals. Now remember, we got x minus 2 twice here, and so we get x equals 2. Remember your multiplicity? Multiplicity is how many of them do you have, and I have 2 of these. So multiplicity would be 2, which means it touches at a point. And it's x squared, so I know it opens up like that. So our graph actually will come down here, touch at this point, and go back up. Now if I'm not sure about that, then I can graph it on my calculator. This is getting really close. I'll let it flip over and do its thing before I actually plug it in the calculator. I tell you some interesting story, but I don't have any interesting story. I could sing the Jeopardy music song, or hum it, whistle it. There it goes. Okay, so there it goes. Okay, now it'll leave me alone. Okay, so actually, I lied to you. I want to close this. There we go. Okay, so let's look at our graph now. Sorry for that momentary interruption. So press y equals, press clear. I get x squared. So x squared minus 4x plus 4, and then graph. Again, if you're not don't feel so comfortable with these, graph them and see. It's going to be obvious. If you don't remember what multiplicity even is, then go graph it and look. Okay, so our question is, when is it less than 0? Less than is below the x-axis. Our graph isn't below the x-axis at all, so this is a no solution case, or empty set if you want to write it that way. Now, if it had been a less than or equal to would be where it touches the x-axis, and if it had been a less than or equal to, we would have one answer. We'd have x equals 2. So again, keep your eye out for the oddball cases. Sometimes it's no solution, empty set. Sometimes it's everything, because it's asking you where the graph is below the x-axis, and maybe it's below the x-axis everywhere. Now the next ones are rational inequalities. Now look at this. Rational inequality means you got a single fraction. So let's talk about how to get rid of those. Or not how to get rid of them, but how to solve them. So solving rational inequalities. Step 1. Get everything on the left side. Zero on the right side. Step 2. Get a single fraction. Rational means a single fraction. If you don't have a single fraction, you can't go through these steps. A lot of these problems will already be a single fraction. Step 3, factor the top, factor the numerator, factor the bottom, the denominator. Set each factor equal to 0. And solve. So set each factor equal to 0 and solve. These are called our critical values. Critical numbers, some books call them. Step 4. Using the critical values, the x-axis, and, I can spell and the graph, Find your answer. Now, if you have a less than or less than or equal to, your answer is below the x-axis. So your answer is below the x-axis. If you have a greater than or equal to, your answer is above the x-axis. Now, if you have a less than or greater than, you're going to use parentheses. If you have a less than or equal to, or you have a greater than or equal to, you'll use brackets. Well, let's take a look at our first problem. We got x plus 3 over x minus 1 is greater than 0. Step 1, get everything on the left side, 0 on the right side. That's done. Step 2, get a single fraction. That's done. Step 3, factor your top, factor your bottom. Well, they can't be factored, so we're done. Set each factor equal to 0. So let's set the x plus 3 equal to 0, and we'll set the x minus 1 equal to 0. And then solve them. So we get x equals negative 3, and we get x is equal to positive 1. And just like before, these are our critical values. Now, using the critical values, the x-axis, and the graph, we're going to find our answer. Our smallest critical value is negative 3, so put that first. 1 is next. Clear over here is negative infinity. Clear over here is positive infinity. Again, these critical values, split them into intervals, like that. Now let's go look at our graph. Now the key to graphing a rational is put parentheses around top, parentheses around the bottom. So let's go plug this in. So press y equals, clear. Do a beginning parentheses, x plus 3, closing parentheses, divided by, beginning parentheses, x minus 1. And then closing parentheses. And then graph. Now, I could care less what the graph looks like. I'm just trying to identify above and below. Our first critical value is negative 3. Negative 3, I don't know, somewhere right here. To the left of it, I see it's above right here. If it's above in part of the interval, it's above in all of it. So that's above. Between negative 3 and 1. Here's negative 3, here's 1. It's below in part of it, so it's below in all of it. From 1 on. Well, here's 1 on, it's above, so it's above. Again, I don't care what my graph looks like, I'm just identifying above and below. Now our problem is a greater than, and for greater than, we say our answer is above the x-axis, which would be here and would be here. So from negative infinity to negative 3, and from 1 to positive infinity. Now infinities always have parentheses on them. Now this problem has a greater than. Remember, a greater than, we said we use parentheses. So we'll put parentheses around those, and since there's two intervals, we do a union symbol in between them. And that's our answer. Let's look at our next problem. We've got x minus 4, x plus 3 over x minus 1 less than or equal to 0. Okay, first step, get everything on the left side, 0 on the right. That's done. Step 2, get a single fraction. We have a single fraction. That's done. Step 3, factor your top, factor your bottom. Well, this is factored as much as we can, so that's done. And set each factor equal to 0. So we'll set x minus 4 equal to 0. We'll set x plus 3 equal to 0. And we'll set x minus 1 equal to 0. And then solve these. And we get x equals 4. X is equal to negative 3. And x is equal to positive 1. Well, let's take our x-axis, put those on there. So negative 3 is our smallest one, so that goes here. 1 is next, so that goes there. And 4 is next, so that goes there. Clear over here is positive infinity. Clear over here is negative infinity. This is splitting them into intervals, like that. And let's go look at our graph. The key to graphing these is, again, put parentheses around the top, parentheses around the bottom. Sometimes you need them, sometimes you don't. It's always a good idea. Just put them there just in case. So press y equals, press clear. Do beginning parentheses on the top part, then beginning parentheses on x minus 4. Closing parentheses on x minus 4, beginning parentheses on the x plus 3. Closing parentheses on x plus 3, closing parentheses on the top part, divided by beginning parentheses on the bottom, and then x minus 1. And then closing parentheses on that. And then graph. Okay, so first one is negative 3. To the left of negative 3, it's below, like that. Between negative 3 and 1. Here's negative 3, here's 1. It's above in part of it, so it's above in all of it. Between 1 and 4. Between 1 and 4, it's below. From 4 on. Here's 4, and from 4 on, it's above. Now, our problem is less than or equal to. Less than or equal to means below the x-axis. This is below here. And this is below here. Okay, so our answer is going to go from negative infinity to negative 3. And then from 1 to 4. Now, infinities always have parentheses on them. Now, this is a less than or equal to. Less than or equal to means brackets. So we put brackets on these. So I'll have bracket here, I'll have parentheses here, and I'll have bracket here, then union symbol in between them. Notice I broke pattern here, didn't I? Put bracket here, I put parentheses here, and I put a bracket here. Why? Well, look where the 1 came from. That particular critical value came from our denominator. If I were to put 1 back in our original problem, we'd have 1 minus 1, which is 0. You can't have 0 in the denominator. Any critical value that comes from your denominator always has a parentheses on it. I'm going to write that down as a note on our second page here. Okay. Note. Any critical value that comes from the denominator. So that comes from the denominator. Always has a parentheses on it. You never put a bracket on it. Let's look at our last problem here. This one is a little bit more exciting. Now I'm not showing any oddball cases with these, but you might have oddball cases with them. That's where you got no solution, or maybe everything's your solution, or maybe everything's your solution except for one value. Okay, we've got x over x minus 3 is greater than or equal to 2. Well, first step is to get everything over on the left side. So I'll take 2 over, and we got x over x minus 3 minus 2 is greater than or equal to 0. Well, we need to get a single fraction. Rational means single fraction. If I'm going to subtract fractions, then they both should be fractions. So I'll rewrite the 2 as 2 over 1. Now the easiest way to get a common denominator is multiply this denominator times this one. So x minus 3 times 1 is x minus 3. And we're going to rewrite each fraction with that new denominator. Now in our second fraction here, we multiplied the bottom part by x minus 3 to get our new denominator. So we have to multiply the top part by x minus 3. Now they already have the same denominator, so I'll merge these together. So we got x minus 2 times x minus 3 over x minus 3 is greater than or equal to 0. Negative 2 times x is negative 2x. Negative 2 times negative 3 is a positive 6 over x minus 3 is greater than or equal to 0. X minus 2x is negative x plus 6 over x minus 3 is greater than or equal to 0. Now, if this is your last math class, that's probably the best way to think of it, because this is the way you've thought of it for a long time. Now, if you're going on to calculus, this one has a little bit of a trick that really does save you steps later on. This is a mixed number form. If we take negative 2 times the bottom part and add it to the top, we can very quickly get to this answer. for example. Negative 2 times x is negative 2x plus x gives us negative x. Negative 2 times negative 3 gives us positive 6. So you can, in theory, go straight from this step right over to there. Okay, we got a single fraction. Factor the top, factor the bottom. I could factor a negative 1 out of the top, but that doesn't really benefit me very much. So I'm going to set each factor equal to 0. So I'll set negative x plus 6 equal to 0, and x minus 3 equal to 0. And solve for x. So here I take negative x to the right side, and we get x equals 6. And here we get x equals 3. Well, here's my x-axis. Here's 3. Here's 6. Here's negative infinity. Here's positive infinity. These split them into intervals. Now we want to go graph it and see what it looks like. Basically, you can graph any of these where you have 0 on one side. Don't want to choose the first one. I could graph this, 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 this. I'm going to choose this one because it's a single fraction. So we'll put parentheses around top, parentheses around the bottom. So let's go put that in. So I'll press y equals clear, do a beginning parentheses, negative x plus 6, closing parentheses divided by beginning parentheses x minus 3, closing parentheses, and then graph. Okay, so 3. Well, here's 3. To the left of it, it's below. Between 3 and 6. Here's 3. Some 6 is somewhere here. It's above, between them. From 6 to the right. Well, it's below in part of it, so it's below in all of it. Like that. Now we're looking for greater than or equal to 0. Greater than or equal to 0 is above the x-axis, which is here. So this right here is our answer, interval-wise. So we'll go from 3 to 6. Now greater than or equal to means we use brackets. So I'm going to have bracket on the 6, and I'll have parentheses on the 3. Why? The 3 came from the denominator. Any critical value that comes from your denominator always has to have parentheses on it. So that'd be our answer. And that's actually the end of that section. So polynomial and rational inequalities.